Hello everyone, my name is Amit Singh and thank you everyone for joining this Cisco Collaboration Facebook group and subscribing to my channel on YouTube. Today we are gonna have a deep dive look on the Cisco IP phone registration process that I discussed last time but has been pending since a quite while, you know. So let's get started without further wasting any time and let's see how the actual Cisco IP phone bootup process looks like. Actually, this is for all the people who are new to Cisco collaboration or would like to learn about, how actually the phone bootup process looks like in case I want to troubleshoot something. What are the steps that I should take care of? So let's get quickly started and let's see how it happens. So let's discuss some little basic thing that I discussed last time as well. So what happens is you see that here is an IP phone, and this IP phone, it has three ports as I told you last time. So it has port P1, it has P2, and it has port P3. The port 1, it will connect to the switch or any other device. So this is the port 1, this is connecting to the switch. And then this port P2, it's an internal 10/100 interface that will carry the IP phone traffic. So it will carry a voice traffic. And after that, there is a port 3, that's an access port. This is the port that will be connected from the back of the IP phone to the uh, computers or laptops or whatever. So that's the access port on the IP phone that's being connected. So this is how the phone will have three ports. So the first port is directly connected to the switch, the second port connected to the IP phone, and the third port, so second, I mean the internal port that will carry the voice traffic, and the third port that will send the traffic to the PC or to the access ports. And now we have to configure this access port, this is which is connected to the switch. And now you could configure it with one of the VLANs for for voice traffic, and then you could add another VLAN for the data traffic for from a device which is attached to this phone, for example this computer. And then you can also configure this access port on the switch to send the CDP packets that will now tell the Cisco IP phone to send the voice traffic in different ways. For example, you can say that, okay, voice VLAN, which is tagged with a layer 2 class of service priority value, or access VLAN tagged with a layer 2 class of service priority value, or uh, you know access VLAN and there is untagged packet. So let's forget for now this, how this voice VLAN is tagged and everything. Let's just focus on the basic things, because this is just for the people who are just the beginners in this voice field. So let's now configure one of the switch ports for a Cisco IP phone. So in the current scenario, what we have is, in my scenario, it's that I have a switch. It's a 2960 switch with 8 fast Ethernet ports and 2 gig ports. And then this switch is connected to a router. For the CME configuration, Cisco Call Manager, Communications Manager Express. And on this switch, I have on fast Ethernet 0/1 one of the IP phones connected. Okay, so on fast Ethernet 0/1 is the IP phone connected, and that's going from that should be in a voice VLAN, and the voice VLAN that we are using is 808, VLAN 808. And why are we using this voice VLAN? It's because creating this voice VLAN, it will enable the access ports to carry the voice traffics from the IP phone, right? So let's now start with the configuration of the uh, switch port fast Ethernet 0/1, and let's create a voice VLAN as well. Okay, so this is my switch, and let's see. I mean, I've already created the VLAN, but let's see how you could create it. It's very simple. You could just say, for example, you have to create VLAN 600. So you just type VLAN 600, and the VLAN would be created. It's just a simple command, you know. And for example, if I have to see all my VLANs, you know, so if I do show VLAN, you will see that all the VLANs are created, and this, for example, is the voice VLAN, and this is active and it is assigned to fast Ethernet port 0/2, 0/3, and 0/4. So let me assign this VLAN to, first of all, port fast Ethernet 0/1. So I will go to interface fast Ethernet 0/1, and then I will say switch port voice VLAN 808, so that this VLAN will be assigned to the switch port fast Ethernet 0/1. And then I will also assign, I will say this is an access port, it is not a trunk port. So I will say switch port mode access, because I have a directly an IP phone connected to this port. And then I will also assign an access VLAN, so that, for example, if I have to connect a PC or something to this port, I could connect it. So I will say switch port access VLAN. My access VLAN, for example, is 802. So now this is in access VLAN 802, and then I will say uh, uh, CDP enable. I will enable the CDP on this switch, and then I will say spanning tree port fast. I will for now not enable or not turn on this port, or because I will not turn on this port because I need to show you guys a little bit more. So now let's just see what happens when a phone is connected to this switch port, you know. So when this phone is connected to this switch port, the switch already keeps sending small pulses, you know, small currents or small voltages on this port, and tries to find out if there is any device connected or not connected. So it every time keeps sending this small pulses, and using one of the phone discovery algorithms, that's the, you know, a switch passes when the phone is connected, this small pulse passes through, or fast link pulse passes through this telephone, and then there is something called as a relay inside this telephone or inside this IP phone, and this relay is usually closed, you know. And once there is a current or a fast link pulse, a small voltage that passes through this phone, what happens is this relay gets opened. And once this relay gets opened, what happens is then the power or the voltage flows through this IP phone or through this uh, device. Or when the power gets sent to the phone, this is the phone then sends a signal, the FLP signal, back to the switch. And this is how the switch then understands, okay, there is an IP phone connected, and then switch knows that the phone needs a power. What switch does is then switch will go to something called as the network management processor, and from there it will check if there is an available power that can be supplied to this phone. Okay, so once because this network management processor does not know how much it has no idea how much power should be supplied to this device that is being connected, you know. So it just does a default power allocation and sends the power to the phone, and over pairs 1 and 2. So it's a transmit and receive pins on this switch through which the power gets transmitted to the phone, and then the phone is taken out of this phone discovery mode to normal 10/100 Ethernet auto negotiation mode. And once the power starts to flow through this phone, then the switch waits for something called as a wait for link timer. So that's usually usually people call it as WFL timer. That's a wait for link timer. This is 5 seconds for which this is the time for which the switch will wait until the phone responds back. And in this time, then the phone will establish a link integrity to its Ethernet port with the switch. And then this is how the power will start to negotiate with the IP phone. So now let's just check how is the power negotiation happening on the switch. How could you check it? Okay, so let's just go to interface fast Ethernet 0/1, and then you will see I will do a no shut on this port, and then I will do a, let's mark this command. It has changed to down, and then it has come up, and then we will say show power in line, and then you will see that this port has detected it's an IEEE powered device, and then it has provided the default 15.4 watts of power. So now it's starting to negotiate uh, the power that is needed on this device. And if I do again, and then it says perfect, it says it's an IP phone 8865. Okay, now you see that it has negotiated. It takes around 5 to 10 seconds, and then it shows now that the IP phone 8865 needs 14.7 watts of power. So once the phone has finished obtaining the power, what it will do is it will boot up using an image. Once the image, so it's the firmware. It's some small Linux based OS, which will ask the phone to boot up, and the phone will execute the image file, and it will start with the firmware. And once it has come up, what it will do, it will send a CTP message with something called as TLV object. That's type, length, and value. That will, tell the switch how much power it really needs, and then the network management processor will negotiate the needed power to the Cisco IP phone. That's what we saw, 14.7 watts for the Cisco IP phone. So once the phone has boot up, so before even getting the IP address, what the phone would need is basically a VLAN information. So it gets the VLAN information when it sends a CTP packets to the switch. And then with the help of this CTP protocol, the switch will assign a voice VLAN to the connected IP phone. And once the phone has a voice VLAN, it will then ask for IP address. And how does the phone obtains an IP address? It obtains it by sending a broadcast packet to the switch, to the broadcast domain. Okay, this is how the phone will request for a DHCP server, and the switch will send this request to the DHCP server via the trunk that is assigned, and the phone will get an IP address. So let's see how this process will happen. We'll see in the logs how the phone gets an IP address once the phone has powered up. All right. So as I told you last time, the DHCP is configured on this router. So I will just start some debug so that we could see those informations. So debug IP DHCP server, I think, server, and I will say I need to start tracking the packet. Okay, so the debugging is on. Let's go to the switch, and then let's turn on the port. So we were on port fast Ethernet 0/1. So I'll say interface fast Ethernet 0/1, and I will do no shut. And now the phone should get the power. And now you see that phone is trying to negotiate the power again. And okay, so the phone has negotiated the power, and let's now see how does the discover message looks like. So here you will see that there is a DHCP discover that has been received from the client with this MAC address, and then it will send an offer to the client, with the informations, with the IP addresses and everything. And then after this, it will receive the next step, which is the DHCP request to get the IP address, and then it will say it has received on the following interface on the router. Once the DHCP request is received, then the router will assign the IP address to the host with the pool from the pool, and then here you will see that an ACK has been sent to the client with the MAC address and the IP address. So now let's see what IP address has been assigned. All right. So the way to check it is show IP DHCP bind. Sorry, show IP DHCP bind. And here you will see that the IP address that is being assigned is 142.102.66.31, and that's the MAC address, and that state is active. So this is how the IP address is assigned to the phone from the using the pool that we have configured on the router. So the next step for the phone is to get the configuration file. So now let's I will clear this IP address again, and then we will see how the phone would request for a register message and the configuration files and everything. So what I'll do is I will say debug syscip all, because the phone is now doing a SIP registration. And then here I will show you what is the message, the first message that the phone sends, and what is the reply that is being sent by the Cisco Unified Communications Manager Express. So now the phone has been started. Again, I just wanted to show you, that's why I started again. Let's wait for the phone to boot up and then get the information about the TFTP server, and then it will show here debug TFTP events. If I do that, you should also see what are the TFTP events that are going on. All right, so here is the output of the debug TFTP events, and here you guys would see that there is a CTL file, there is an ITL file that the phone requests, and then it requests for ITL file.tlv. It doesn't find that, and then it looks for the MAC address.cnf.xml file, and then it looks in the flash. The router looks in the flash because it's a Communications Manager Express, and then it finds this file in the flash and sends it across to the phone, and then it sends the language files .jar file, and then it will send the tones that are needed, the ringtones and everything, and then app dial rule XML file, soft key XML configuration file. And once it has sent all this information, the soft key template and the configuration file and everything, then the phone knows where should I send my first SIP register request. So this information, where do I send my first SIP register request, is inside this SEP macaddress.cnf.xml file. So let's see now how does the first register request looks like. So this is, I will just copy this two things here. So you see here that this is the register request. I will, yeah, hopefully now it's better. So you will see this is the register request that has been received via. So that's via header is the source from where the request has been received. So it's from the IP phone 142.102.66.31 on port 5060. And this is the directory number. and this IP address is the IP address of CME, so it has been sent to the call manager express. Okay, so this register request has been sent, and then you see that there is a 200 OK being received. So it has been sent from this IP address, and this has to go to 142.102.66.31. So that means that phone has received a 200 OK and it could register. Okay, so these are the phone registers, and now let's see what is inside the configuration file. So in the configuration file, you will see there are some parameter lists, and in the XML file, you have the name of the device or the MAC address, and then it has the IP address of the device and default gateway, and then a lot of other information. For example, what's the voice VLAN, and then let's say, yeah, you see here the Unified Communications Manager IP address. From here, it gets the Unified Communications Manager IP address, and then it tries to communicate to CUCM over this IP address to get its configuration file. Okay, and then it sends the register to the Cisco Unified Communications Manager over this IP address. And you see that also the VLAN information. So there are a lot of information in this XML file that the phone receives. Okay, so I could show you, do show voice register pool one brief, and you see that this IP address of the phone and this is the MAC address that has been registered with Cisco Unified Communications Manager Express. Okay, so my main intention of this video was to just show you guys the complete end-to-end process, how the phone starts to boot up, how it gets power, and how it gets the IP address from the DHCP, and over which VLAN and everything. So I hope now you have a clear idea about the phone boot up process, and you could start troubleshooting a lot of things, to understand this by understanding this process a little bit more in deeper. All right, guys, then I thank you very much for viewing this video, and I hope this was informative to you guys. If you think that was useful, then do not forget to please share it with your colleagues, and keep subscribing to my channel and joining the Facebook collaboration group so as to share a lot more information. All right, then keep learning, keep growing, stay safe. Thank you very much. Bye bye.